Hello students, I welcome you all to the e-learning sessions of LT Institute of Engineering and Technology. Myself Hardik Shah, and today we will discuss about Morse test and Williams line method to finding the power. Okay, so I hope you will see this video till end to completely understand the topic and to gain your automobile skills. Fine, so let's start our video. You have to find indicated power, right? So what is indicated power? That is IP, okay, and it is actually the power generating inside the cylinder, inside the engine, okay. So for that, what we need to cover, you have one formula, that is IP equal to LANK upon 60 into 1000, okay. So what you need to find? You need to find pressure, you need to find the RPM, then you need to see what is the type of engine, 4-stroke and 2-stroke, and thereafter you can find the IP. So basically the more tedious work is in finding pressure, that is PMB, or you can say PMI, that is mean effective pressure, right? So we have to find mean effective pressure inside the engine. So for that there is one method, it is called indicator diagram, okay. So what is indicator diagram? It is nothing but PV diagram, okay. So we need to set the rotation or the reciprocation of the piston inside it, and we need to trace the position of it, and thereafter we will cover up what is the volume covered and what is the pressure generated, and thereafter we will get that mean effective pressure, okay. So it is very tedious work practically, and it is not always possible to find practically pressure inside the engine every time. Fine. So without finding the pressure, without finding that PMI, we need to find that IP, and for that there is one method. It is called Morse test, okay. So in Morse test, what we are doing, we are actually finding the indicated power of the multi-cylinder engine without finding the pressure, okay. So we will see it in some of the next minutes, okay. So stay tuned and let's start to the first test, that is Morse test. So what is Morse test? Morse test is used to find indicated power of, or you can say frictional power of, each cylinder of the multi-cylinder engine, okay. So here we have taken 4 cylinders. So this will be done without using indicator diagram, okay, PV diagram, okay. Here you can see a brake dynamometer. So these are the 4 cylinders and this is brake dynamometer, okay. So when all the cylinders are in operation, as you can see over here, so all the cylinders are in operation, right. So the brake power of the engine is measured by brake dynamometer. So we will use I1, I2, I3 and I4 as indicated power of cylinder, that is 1, 2, 3, 4, and we will use F1, F2, F3 and F4 as frictional power of all the cylinders, okay. So brake power of the engine can be calculated as total indicated power minus total frictional power. For finding the total indicated power, we have to add all the indicated power of the all cylinders, okay. So we can write it is I1 plus I2 plus I3 plus I4, that is the total indicated power, and total frictional power we can write at F1 plus F2 plus F3 plus F4, okay. So we got brake power of the engine. Now you have to remember this formula because this formula will be used again, okay. So here what we will be doing, in a cylinder 1 we will be cutting off its power, okay. So it is or it does not develop any power. So how this will be done? For petrol engine, short circuiting of the block cylinder 1 will be done, okay, and for diesel engine we will cut off the fuel supply inside the cylinder, okay. So by doing that, what we will be doing, we will be cutting off cylinder number 1. When cylinder number 1 is cut off, and we can say I1, it is indicated power for the cylinder 1 is equal to 0, but friction loss of the cylinder remains same. So if the power of remaining cylinder will be B1, that is BP1, that the power and cylinder 1 is cut off and it will be equal to 0, because here I1 is 0 plus I2 plus I3 plus I4 minus the total frictional power, that is F1 plus F2 plus F3 plus F4, okay. So here what we have done, we have cut off cylinder number 1 and found brake power of the remaining 3 cylinders. So next what we have done, BP minus BP1. So as I told you, you have to remember the formula of BP, okay. So here we have put that formula of BP, that is the BP formula, that is BP minus BP1. So what will happen? Because of this subtraction here, it will be I1 minus I2 minus I3 minus I4 minus F1 minus F2 minus F3 minus F4. Okay. So after subtracting, what we will have? We will have I1. So we got the brake power minus brake power 1 is equal to I1. So we can say integrated power of the cylinder 1, that is I1, is equal to BP minus BP1. Okay. So here formula will be helpful. Now because we will find the integrated power of other cylinders also by using the same method. So now what we will do? We will be doing cutoff of the cylinder 2, 3, 4 and 1 by 1. Okay. So we will find the brake power of remaining 3 cylinders. So we can do in this way. Okay. We can cut off, for example, cylinder number 2, then we can find the brake power of the remaining 3 cylinders. Then we will cut off cylinder number 3. So we will find all the brake power of remaining 3 cylinders. Okay. Then we will cut off cylinder number 4 and we will find the brake power of remaining 3 cylinders. Okay. So by doing that, what we are doing, we will have indicated power of the each cylinders, that is cylinder number 2, it will be I2, that is equal to BP minus BP2. Indicated power of the cylinder number 3, it will be I3, which is equal to BP minus BP3. And indicated power of the cylinder number 4, that is I4, is equal to BP minus BP4. So here we have found indicated power of the cylinder 1, cylinder number 2, cylinder number 3 and cylinder number 4. So total indicated power of the engine, as we know that IP is equal to I1 plus I2 plus I3 plus I4. Okay. And what we can do, we can now put that we will get brake power, that is brake power minus brake power 1, brake power minus brake power 2, thereafter BP3, BP4. Okay. Because your indicated power, total indicated power, it is the summation of all the individual indicated power. Okay. So by doing that, we have done brake power over here. So we have done, because it is all positive and we have taken here, and whatever is negative we have taken on second side. Okay. That is brake power 1, 2, 3 and 4. Okay. So here we have 4. So we can say that IP is that indicated power equal to 4 times brake power minus brake power 1, that is BP1 minus BP2 minus BP3 minus BP4. So here I can take minus sign. Okay. So minus sign and that 4 is common. So you will get the formula of the IP, that is 4 times brake power minus all the summation of brake power 1, 2, 3 and 4. Okay. So we will get all this IP, that is IP1 plus IP2 plus IP3 plus IP4, and thereafter we can also find the brake power that is already given. So we can find the efficiency of the engine. Okay. So by cutting off each cylinder 1 by 1, we can get this formula and we can get the indicated power of whole engine. Okay. So we have calculated in this manner and this is called Morse test. Okay. So you can say that the total indicated power is I1 plus I2 plus I3 plus I4. That can be also converted into brake power formulas. Okay. Like 4 times brake power minus brake power 1 minus 2 minus 3 minus 4. And the same way frictional power can also be found in this manner, only by substituting the brake power into the frictional power. Okay. So what is happening? So frictional power, that is FP is equal to IP. Okay. So IP minus BP. So we can also calculate the frictional power also. So that was the first method, that is Morse test.
So now let's discuss about the industrial application of this Morse test. So the basic task of the development engineer is to reduce the cost and improve the power output and reliability of the engine, right? So trying to achieve these goals, there is various design concepts to find the effect on a engine performance of a particular design concept, to restore the engine, to test it and understand it. Okay. Thus in a general, developments of the engine will have conduct a wide variety of the engine test. Okay. So an IC engine is used to produce the mechanical power by combustion of the fuel, and this power is referred to as the rate at which the work is done. So power is actually expressed as the product of the force and the linear velocity, or we can say product of the torque and the angular velocity, right? So in order to measure this power, one needs to measure the torque or we can say force and the speed, right? So the force or the torque is actually measured by the dynamometer and the speed is measured by the tachometer. So the power developed by the engine and measured at the output shaft is called actually brake power. While calculating the brake power for the single cylinder engine, it is very easy, but in a case of multi-cylinder engine, it is actually quite difficult because the inertia forces are actually developed inside engine. Okay, so in such cases, this Morse test in industry can be used to measure the indicated power and mechanical efficiency of the multi-cylinder engine. That's why we need to do this Morse test. Okay, so this was the basic reason why it is used in industry. So while we are developing any future engine, we always do Morse test one time to get the perfect power is coming from all the cylinders or not. Okay, so this was the basic about the Morse test industrial application. So that's it in today's session. We will meet in next session. Thank you. Goodbye.